Hi guys, this is organic chemistry and we are looking at structural isomers. So one of the type of structural isomers is called chain isomers in which we have presence of branching. So in all isomers, they have got the same molecular formula but different structural arrangements. Now we take an example of a 5 carbon chained alkane. So in a straight chain, it would be called pentane. So it would be CH3, CH2, 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 and then CH3. Now the molecular formula of pentane would be C5H12, which will be the case with all of its chain isomers. All of them will have a molecular formula of C5H12, and this will be called pentane. Now, if we take out one of the CH2 groups and convert it into a substitute group on the remaining chain, so the remaining chain will contain 4 carbon atoms, so that would be CH3, CH, CH2, and CH3. The reason the second carbon atom was written as CH was because one of the hydrogen will be replaced by the CH2 group. The hydrogen removed will be added to CH2 to convert it into CH3. And in this way, we have introduction of a branch in our 5 carbon chain alkane. So the numbering would go from left to right, 1, 2, 3, 4, and the name of this compound would be 2-methyl butane. Now, 2-methyl-butane has also got 5 carbon atoms and 12 hydrogen atoms, making it a chain isomer of pentane. Now, removing the remaining CH2 group and converting it into a substitute CH3 group, we end up with a carbon atom in the center bonded to 4 CH3 groups on each of its bond. So the name of this compound now becomes 1, 2, and 3. So this is the parent compound. So we have 2, comma 2 dimethyl and 3 carbon alkane is called propane. Now 2,2-dimethyl propane is also a chain isomer of pentane having 5 carbon atoms and 12 hydrogen atoms. So in this way, introduction of branching results in formation of chain isomers. The next type of structural isomers are called positional isomers, in which the position of the functional group changes. So we take the example of uh, 4 carbon alkene. So the molecular formula of this compound would be C4H8, which would be the same in all the positional isomers formed, and the compound would be CH2 double bond CH single bond CH2 and single bond CH3. This will be numbered from left to right, 1, 2, 3, 4, and it will be called but 1 ene. Now, a positional isomer has a change in the position of the functional group. The functional group here is the double bond. So we have CH3, CH, double bonded to CH, single bonded to CH3. Now the position of the double bond has changed. So the numbering begins from left to right, 1, 2, 3, and 4. As we can see, the second and the third carbon atoms have a double bond between them. So the name of this compound becomes but-2-ene. Taking another example of positional isomerism, let's take a 5 carbon alcohol. So that would be having a molecular formula of C5H12O. So the first member of this positional isomer group would be CH3, CH2, 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 and OH. So the name of this compound would be, when the numbering starts from right to left, 1, 2, 3, 4, 5, it would be called pentane 1 all, with the OH group being present on the first carbon atom. A positional isomer for this compound would be CH3, CH2, CH2, CH, CH3, and the OH group being present on the carbon atom with a single hydrogen on it. So the numbering would begin from right to left, 1, 2, 3, 4, and 5, and the name of this positional isomer of pentane 1 becomes pentane 2 all. Another positional isomer of pentane 1 is CH3, CH2, CH, CH2, CH3, and the OH is positioned on the CH group. Now the numbering can begin from left to right or right to left, because this is the central carbon atom. So 1, 2, 3, 4, and 5. The name of this positional isomer is pentane 3 all. So as seen by the two different examples of positional isomers, a positional isomer is an isomer with the functional group in a different position. Functional isomers are isomers in which the functional group changes. So the molecular formula remains the same, but the functional group changes. So we will be looking at four different sets of functional isomers. So let's begin with the first set, which are alkenes and cycloalkanes. Now, alkenes and cycloalkanes are functional isomers because they've got the same molecular formula, but they have different functional groups present. So the molecular formula that we will take would be C4H8, and the alkene that C4H8 forms is CH3, CH, CH, and CH3, and the cycloalkane that C4H8 forms is CH2, 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 and CH2. So the name of these compounds are but2ene in the case of the alkene and cyclobutane in the case of the cycloalkane. It is better to make this CH2 on the left as carbon being exposed to the other carbon atom in the bond like this, and H2 written this way. So this would be a better way of making cyclobutane. So this is the first set of functional isomers that we have seen. The second set of functional isomers is the combination of alcohols and ethers. For this set of functional isomers, the molecular formula that we will be using would be C2H6O, and the alcohol that C2H6O represents is CH3CH2OH, called ethanol, and the ether that this molecular formula represents is CH3OCH3, called methoxymethane. So this is the second set of functional isomers that we have seen. The third set of functional isomers are aldehydes and ketones. Now, aldehydes and ketones are both carbonyl compounds, and both of them are functional isomers. So, the molecular formula that we'll be using for aldehydes and ketones is C3H6O, in which the aldehyde that we would be making would be CH3, CH2, CHO. This is the aldehyde, which will be numbered 1, 2, 3, and it will be called propanol. Propanol. And the ketone that this would produce would be CH3, C double bond O, and CH3. And this will be called propane 2 one. So these are the aldehydes and ketones that are functional isomers of each other, both of them having the same molecular formula but different functional groups present. The next set of functional isomers we would be looking at would be the set in which we have carboxylic acids and esters. And the carboxylic and esters we would be looking at would have the molecular formula of C3H6O2. So a 3 carbon carboxylic acid would be CH3, CH2, C double OH. The numbering would begin from the C double H carbon. So 1, 2, and 3. This will be called propanoic acid. And the ester that this would form would be CH3, C double bond O, single bond O, and CH3. And the name of this ester would be methyl ethanoate. So this is the fourth set of functional isomers in organic chemistry. So functional isomers have the same molecular formula but different functional groups present in them.